There is an x that makes it true. There is one x that makes that true. And it's nothing crazy, you know, it's not like that it's 19.6538295. Okay? It's something reasonable to get just with doing normal basic math stuff. Hey, you guys could have your homework, that worksheet out too, right? Great day to check homework because you got most of you got done in class, right? It's a great day that you couldn't have forgot to do it because lots of you got it done in class. We sold these calculators. We sold them when we bought pizza yesterday.
That's all.
With the money? Yes, we don't need calculators. See if you can try to work your way. Try to think of ways to work through there. Yes, you do. Maybe it's in the message. Is it in your math notebook, maybe? You know, like your notebook that you've been making? Let's say that's it, so you have it. Okay. You're doing geometry now too. Does that go okay? It's gonna be hard taking 2 math classes at once.
Yeah.
So just worry about that.
Oh, you know I'm tired. I'm close to You still
still friends with Brian?
Hmm?
You still friends with Brian?
Ryan.
Adkins, the other
Yeah.
guy? I don't know why. I'm kind of surprised about that.
Yeah, well, I mean, first you have to just do it. You get away with it together.
Really?
And him away with him.
What don't you like about this question?
Everything.
You don't like all the decimals?
No.
Would it be better if I could just make them disappear?
Yeah.
You'd like it better if it didn't have any decimal points?
Pretty much, yeah.
Okay, I am going to just make them disappear. Is that what you did? You make them disappear? Uh-huh. Then
You just
then
add
it's
them all
that
together?
similar. Not really, but I do gotta make sure that you recognize some things called terms. Terms are separated by just overall add and subtract signs. So I know it's gonna be tough to convince you this, but there's just 3 terms up there. Even though this is one big ugly thing, it's all glued together, and it's called a term. And here's what we're gonna do. We're gonna go multiply everything we see up there by, what'd you multiply by?
I just combined all the terms. Like, I combined the,
So did you go ahead and multiply this out?
yeah.
Oh, okay. Well, we can do that, and we can go back and do it. That is one way, and I might erase mine and do it then it's your way. But I'm gonna go to multiply this, 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 then I got something over there. Everything by 100. Gonna multiply everything by 100, and I think you're gonna like it better what you see. Everything by 100. Cause see, it's an equation. You can do whatever you want, but whatever you do to one thing, you gotta do to everything. Multiply by 100. What do you do with the decimal point when you multiply by 100? 2 places to the right, huh? So watch for this one. When I multiply this thing, this term, by 100, we just go root, root. That's now a regular 5. 5x look better? Okay, let's go do just this decimal point. This is just one thing, so I only want to move one decimal point by 100. 2 places, what does it turn into? 10. Mm-hmm. Now, still got this stuff here, though. And I'm just going to multiply the thing, so just move one decimal point, 2 places. That's now 25. You still got this. And what happens when you don't see a decimal point and you multiply by 100?
Always to the right.
2 places still, because it starts out right here. You don't see it, but it's at the end. So 2 places, yeah, it goes all the way to the right, plus 2 more, huh? So now that's 2,000. And what do you think now? See, it looks better? Probably looks better, doesn't it? So then what would we do? Distribute. All right, let's see. Let's go ahead and, want to distribute this 10 or you want to do the 25? The 10, what's 10 times 2x? 20x. Okay. Let's go get this done. What's 25 times 100? 2,500, yeah. Minus, what's 25 times 3? You don't need a calculator. Yeah, 25, 25, 25, 3/4. You guys know what 3/4 is. That's 75x. Alrighty, let's see. Now, we got the parentheses taken care of for distributive property. Any like terms on the left? Wow, we got a bunch of them. Look at them all. How many x's does that make? And you get big money. You don't need a calculator. 5 and 20 makes 25. That's 1/4. Here's 75, but it's negative, so you subtract the 2. You know, 75 cents minus 25 cents is 50 cents, and I have more negatives. So there's negative 50x. What did we call just numbers yesterday? What word did we say numbers without any variables? constants. So we do have plus 2,500 that equals 2,000 over here. Now what should we do? This is a 5, it looks like a 3, doesn't it? Sorry about my sloppy. Yeah, get rid of this. And I'm going to have to move all the way up here because I'm out of room. I see negative 50x equals negative 500. The answer is 10.
Yeah, that's what I got. Yeah, I did do all those confusing steps.
Matt, tell us what you did that just looked a little bit different.
I just distributed first. So I distributed 0.01 by 2 and got 0.2x.
Hold on, let me catch up. Okay.
And then I distributed the 0.25 by 100 and got 25 minus 0.75x.
Okay, then what?
Then I subtracted, I combined all the like terms on the left side. And I got 0.5x plus 25 equals 20. And I subtracted 25 from both sides. Got negative 0.5x equals 5. Then I divided 0.5 by each side and came out with 10.
Okay. See, not crazy. Not
That's what I
crazy.
did.
What's that?
That's what I did too.
That's what you did? Yours does look like an aspect there, doesn't it? Yeah. But then again, you know, and it worked. If you're just really careful with those decimals, yeah, you can deal with them. You can get it right. You guys are proof that you can get it right to do that, huh?
We did the easier one.
What's that?
Looks like that's the easier one.
And it might be,
They're
but it
doing
might
all
be.
those steps.
But a lot of people, they were all nervous. You hear them like the way they want their calculators. They saw those decimals and thought they needed a calculator. So I thought maybe we'd just talk about how to get rid of them. All right, 10's good. We'll see. We'll get you some trees turn a little bit. Let's pull out your homework. So what do we have? 6 of them? 5 of them? 6 of them? That'll make just the right amount of space then, I believe. Which one you want? 4? You got a 4. Which one does this table want? 1. Table back here, you can't have 4 or 1. Which one somebody want? 3. Their turn next time, you know. Table back here, what's left? 1 and 2 still left? Nope, we got 2, 5 or 6 maybe. 2, 5 or 6? 2. You got it? Thank you. You got 6? You still need a 5? 5 spoken for anybody? You do. Thank you.
Yeah, right.
Exactly why I didn't trade.
Which one are you doing for? You do whichever one you want. Whichever one you like better.
0 plus 6 equals 6. And then.
You have to have a variable, so.
No, because if you,
So did I, Soraya.
This is
I did too.
No, it doesn't.
What?
You
I
don't
got
even
60
do this,
left.
like, what's
Oh.
on it?
Coded wrong through email,
I had to put-
below
you think
stuff,
I had to-
third period and fourth and all, that is all straight out, so if it doesn't say, this is not, shoot. Finish with this.
Right.
That's right here.
Go ahead.
Please agree. Thank you.
Whatever you, whatever you.
See, you're gonna be wrong.
You got 4 0, right.
Oh, well then we might be in trouble. I don't think so.
But,
I don't know. You don't think it's right? Is it good?
That's right,
We're
it's
gonna-
good.
We're gonna petition.
No, I don't think so.
No?
I don't think so.
No, you don't think you were 60.
Remember, this is just an equal sign, that's actually a positive 5, alright? So you would do exactly what you said, you add that to your, like terms, and then once you do like terms, you do that.
I can't wait till I'm old enough to get major surgery. That way I don't have to work these anymore.
Those might not be right. I don't know.
Maybe I'm
You have your variable in this one.
Okay.
You take that,
I'm old enough to at least. But
I heard it's not really a good thing to do.
it improves your vision immensely though.
Now we
Like,
gotta talk
makes your
about
vision
what that
20/20
is.
or less.
It's all weird, isn't it?
we left in a fractional form, you just broke it into a.
And your eyes are open to
Alright, I'm going to have
Yeah, I know.
They don't put you to sleep or anything. You see
What does
everything.
this say right
I
here?
know, but they numb your eyes at least.
Yeah, but still you see everything. Oof,
I
couldn't
think
do
that's it.
that.
They use some
I get
laser
it.
or whatever.
I may be a junior, but I'm dropping out. After she got questions.
My mom said it's like looking into a kaleidoscope.
I'm already halfway done. I'm dropping out now.
I don't know if I can do that.
It would always be true.
She's right.
You may find that the folks at the board did things in a different order. That's okay, as long as whatever they did to one side, they did to the other as well. So for number 1, the G should be a -3. It's probably not coincidence if on your paper you got G as -3. You're probably not just lucky that you got it right. You did stuff that is okay. Number 2, looks like they combined their 5 and their 11 to start with. And that's where they got 16. And then looks like, started working from that, looks like then, let's see, I'm trying to figure out where your second line joined your third one. Looks like you were at -12 equals -6n plus 16. I am thinking you subtracted 16 from both sides. Said -28 equals -6n. Just not sure why you flipped them. Okay, if you want to though. 4.6 it repeats, or 4 2/3. So that's all just fine. Number 3 is looking good. Number 4 is looking good. They decided to multiply everything by 9 and just get rid of the fractions. W equals 61. Number 5 decided to subtract 4 p's from both sides and then subtract 11. P equals -1. And 6 was weird, and it was weird on purpose. So let's see.
I don't like it.
Do make sure when you took -2 times -3, that's a +6. Make sure negative times negative, you're out positive. And now you got -2j plus 6 equals -2j plus 6. I don't know what you mean by cancels here, and I just want some room to work. I think I know what you mean, that if I subtract 6 from both sides, there's nothing there. If I add 2j to both sides, there's nothing there, but that means 0 equals 0. And here's the way I think about that. How often does 0 equal 0? When does 0 equal 0? When is 0 worth the same as 0? Always, all the time. And some of you might have took different steps And some of your papers might say 6 equals 6. I'm trying to think what else I saw. That's okay, you just did stuff in other order. When does 6 equal 6? All the time. And so you're looking for the J's that make this true, and the answer is all the time, which means, it means anything you pick for J works. Anything you pick. I promise you it'll work.
So you'll still get 0?
You won't get 0. Watch, so let's just go back to this original. It will, whatever you pick, you'll see, we're gonna get the same thing on both sides. So here's the original. Somebody pick something for J, don't do decimals, fractions, let's make it easy. What? 17, alright, so I'm gonna pick, is J at 17? I guarantee I'm gonna get something on the left that matches on the right. So 17 minus 3, that would be 14. And negative 2 times 14 is negative 28. Over here, negative 2 times J. Negative 2 times J would be negative 34. Negative 34 plus 6 is negative 28. It doesn't matter what you pick. Pick J of 100. 100 minus 3 is 97. Negative 2 times 97, 194, I think, 194. Negative 2 times 100, negative 200. Negative 200 plus 6. Doesn't matter what J you pick. So if you get that, and that's hard to follow, whenever you get something like, and who knows what it might be, you might get negative 18 equals negative 18. You do all your work and you get that, you go, oh, I must have made a mistake. The answer is all real numbers. You know, what does J? It doesn't look like J, does it? Where normally you write J equals, you can say J equals all real numbers, because anything you pick is going to work. Now I got another weirdo that might happen. You might do everything right for a different problem, and this might be your result. You might get something gibberish, like 8 equals 20. And here's what I say to myself. So, when does 8 equal 20?
Never.
Never. And so it's a problem that there are no J's that make it true. There's not even any imaginary numbers that make it true. Never. No solution. And then, if we had J's, you might just say, no solution. There aren't any J's ever that make it true. Okay? We're just going to practice today. You need the whiteboard. Whiteboard, marker, and an eraser. If you like that little flip chart in your notebook, have it out. If you don't think you need it, don't bother.
Add new emphasis. Like a little helmet style thing.
Okay. It is practice time. Your first problem says 4n minus n minus 1 equals 7. I don't remember any weird stuff happening on these, you know, like all real numbers work or no solutions or anything. Now we'll try to throw something a little bit now. Some of you might like to think of this problem like this. Where instead of just thinking of distributing a negative, that it's negative 1 times each of those, same thing's going to happen, same result will happen. take, make this stay, make your next line stay. Opposite of n, opposite of negative 1. And it starts with that'd be 3n.
And then for the calculation, you distribute it to negative, right?
What in the world? Is that good?
And then you're gonna have your negative 1, right? Negative n, 1, right? Confusing. Try that again. What you got?
Motion.
Thank you.
Negative cross, yep. Added. Combine like terms, right? Should have given you that's the negative 1, and that's positive 4n.
Can I get this right?
They're not on the-
No, it's 2. Here's, I found it. When you took negative 1 times the n, that's right, but negative 1 times a negative 1, positive 1. Here's where we want to start. We got the opposite of n. When we distribute with this negative or the negative 1, opposite of n is negative n, opposite of negative 1, or negative 1 times negative 1 is positive 1. Put your like terms together and call it 3n plus 1. Subtract 1, 3n is 6. And it's 2. Pat yourself on the back. Let me see you. Let me see you do it. You got it right? Pat yourself on the back. Alrighty. Let's bump it up a little bit. 2/3 x plus 80 equals x plus 25. Sometimes I like to write my stuff out real wide and have space in between the stuff to go back and alter it a little bit.
X over 1 or 1 over x?
X over 1.
Now I suppose there's somebody that's going to start whining about that fraction. You got any whiners?
I'll go ahead.
Come on, whine with me.
I'll
Oh,
go ahead.
I
I'll go
don't
ahead and
like
whine.
fractions. Let me hear you whine. Give me your best whine.
I don't like fractions.
That didn't sound like a whine.
Yeah, it wasn't a one. I'm too tired to think it.
And some of you might be thinking, I don't like that fraction, so I'll change it to a decimal. Well, the decimal for 2/3 is 0.6 with a repeat bar, and then you just get into trouble because your calculator doesn't have that repeat bar over the top of it. So let's do this. Here's what I see. Divide by 3. So let's go take, multiply this by 3, multiply this by 3, multiply this by 3, multiply this by 3, and then I'll make sure you're set up to take over. Because the divide by 3 will undo the multiply by 3, and now you've only got 2x. 3 times 80, just do 3 times 8, you know that, that's 24 with a 0 on the end. 3 times x, and you know that 3/4 are worth 75, and now take over. And it's the same equation without the fraction. Fractions are like green beans, they're good for you.
I like green beans. I just don't like fractions though.
Well, then we get rid of them, see?
But what if I don't want to get rid of the green beans?
Well, then you need lima beans, or peas,
I don't like lima beans or peas.
asparagus,
No.
broccoli.
No. What's that has cheese on it? Broccoli with cheese is amazing. It's not healthy, but it's good.
I think I see a lot of right answers. I'm seeing the same thing. Yeah. You sure could. You can do anything you want. Just sometimes it doesn't help, but that will start leading you to some progress. Yep.
You should ask for the
I don't think
They catch up there, so you had that 675 per minute, didn't you?
Why? You don't want to get rid of 3x.
there would be X's.
This one?
I think that's all right.
It's just not necessary.
Yeah, that's the same.
Not 5 X's. These are on the side. Yeah, just really look, so you can put this on the If you were to just subtract 3 X's on the side, that's what happened up here, you took it away. You took 3 X's away here. So now it's on. If I take 3 X's from here, that would be a negative. I think you'll get right into that.
Could we, if we had done this at the beginning,
So you don't want to keep on?
And made it 2x over 3.
I still don't. That's what it'll be, right?
Uh-huh.
Yeah. You were close on it. You were close on it. Yeah, okay. I remember that answer.
Yeah. I see a whole lot of 165s out there, and that makes me happy. Next is 165. I don't know what you did. I'll try to do something different than what I saw. If I subtract 2 x's from both sides, then I'm here. And then subtract 75, and that's where you got your 165. See, you made it with the fraction, you're not even nauseous. And in fact, that was so nice, let's try one that's got 2 fractions.
Oh, come on,
Just like your mother. Right, it's all up for you, right? Huh?
That's a Y.
That's a Y. There's a 4 there. Starts out with a 4, so notice the difference between the 4 and the Y.
That's supposed to be positive 5, right?
Yes it is. It's equals 5. There is a lot of dirt up there.
It just kind of looked like it was dirty, right?
Now let me get you off to a good start so you don't get all tangled up. The first denominator that I see is a 2. And you're allowed to multiply everything by 2, but look up here. Multiply by 2, okay, multiply by 2, multiply by 2. But when I get to here and I multiply by 2, it does get rid of that 6. So, let's go and look and see if we multiplied everything by 6. So let me show you what that looks like. So you'll just have that little tool in your pocket for the next time. Multiply everything by 6. I'll show you. Some of it's easy, some of it's obvious, right? 6 times 4. Here's the one that's a little bit weird. That 6 is really 6 over 1. Now, depending on how you see this, you can either see it as 6y over 2. That's okay. What's another name for that name for 6y over 2? Oh, over 2, divided by 2.
4-1.
6 divided by 2.
3-1.
Here. So 6y over 2, do you see it? That's the same. 6 divided by 2 is 3y. And that's okay, if you want to think of it that way. Here's what I do. 2 into here goes 1, and 2 into here goes 3, so then I just have 3y over 1, which is just 3y. I'm thinking the same thing. I can just physically see the divide. Then here's 6 times 5. That's easy for you. And then here's the kind that you like. Divide by 6 cancels out, multiply by 6. There's just y. And then you go from there, and then there's no fraction. So you should be starting with 24 minus 3y equals 30 plus y. You get an answer real quick, so I can just get it real quick, I guess.
That's correct. I did it kind of different.
see what it is for this girl. It looks like you,
Add this and this, would it be 2y over 8?
probably not. And so what you wanna do is, when you're saying, have y over 6, you wanna add y over 2. When you add fractions, you gotta get common denominators. That didn't change, so that won't change. 2 times 3 turned that into a 6, so we have to take that times 3. So instead of having y over 8, we have y plus 3y. This ought to be 4y over 6. So that's why I like to multiply by something, just get rid of it. That is right, when you simplify that. Okay, that's right so far, now just go that much further and fix it. It is. So let's fix the 24 minus 2y minus y minus 3 negative
Because it would've caused a problem when you got the y over 6, the 1 over 6, y over 6. Because then you would've still had, if you would've,
Oh.
I believe it's negative 1.
Wait, no, I don't know that it should be. How did you get that? What did you do? Yes, you subtracted a y. Subtracting a y, you're at negative. And subtract another one. You're at negative 3. Like if I'm on a number line. And I'm at negative 3. And I subtract 1. And then go back and subtract 1. And I'm on the left.
What are you doing?
So, it's 1 1/2. That's right, when you get it back. The answer, and I'm going to finish it up here and I'll point out some of the mistakes I saw. The right answer is negative 1 1/2 or negative 3/2, or some of you had negative 6/4 and we're getting ready to finish it. The biggest mistake that I saw happened right here. At some point, might not have been your very next step, in that subtracting that y from both sides. That's what you want to do, it's just what you wrote down after that. So this side's got 30, here's 24, but if I'm at negative 3y, take another one away, if you're already on a number line at negative 3, and you take 1 away, you are now at negative 4. So negative 3y, take away another y, is negative 4y, and some of you had a 2 there. And then I think maybe I'll subtract 24. So now I see negative 4y equals 6. Divide both sides by that negative 4. And there you see y is negative 6/4, which is negative 3/2. Let me show you something else. Just when I had this, 6 over negative 4, realize that's the same as this, which is the same as putting the negative out front, because a positive divided by a negative is negative. A negative divided by a positive is negative. It doesn't really matter where you put that negative. Throw it all, one of each, which makes it negative. Okay. Well, this next one, you're going to think it's awfully easy compared to this stuff. Yeah?
Well, no, I mean, I'm sure you can because I got the right answer, but you can always add 3y to y, right?
Oh, absolutely.
It
Absolutely.
doesn't matter which way you do that.
No. And then you didn't get into that little mess anyway. Then you had 24 equals 30 plus 3y. Yeah, no, that's all fine. Some people will do that to avoid the whole negative.
Yeah.
Mm-hmm.
Too many notes.
I was just thought that way because, if you add, it's easier than subtract. I don't know, it's like...
It is. Everybody's more comfortable with
Everybody
positives
hoping
than
out.
negatives. Yep.
Already.
Here, I told you, you'll think this is real simple then. fraction. Negative 9 plus 2 times the quantity of x plus 6 equals 28.
I don't know what you should use as a calculator. What'd you get?
And if you find it, that looks so wonderful. I don't even see it. Oh, I found it, right here. That's funny, like when you took your 2 times your x, 2x,
Where you
2
subtract
times
that
6.
out. Mine's like
I did
30.
it all the time.
It is really, really hard to find your own mistakes.
You can multiply and negative 9 combined.
Well, no, I can't find my mistake off that. I go across the hall to Mr. DeStinci all the time and say,
Three, right?
I know there's a mistake in here, can't find it. And it'll be something like that.
2x plus 3
It's 12 and a half.
Now you bring it.
When you went 2 times x, that's 2x. 2 times 6 is 12. That's right. Finish yours up, but I bet you're right. Oh. Let's see it do this. Remember we do multiply first. So you did an add. Remember really, when something's next to it, it's a multiply. So, we can't put those together. And the other thing, out of your little flip chart, there's a little bitty parentheses. Go ahead and distribute that all out.
And then
I see the phone, I think it's just when you're not finished with the problem. Do something. Do something. You see any like term? About the 9 and the 12.
I like
That's a negative 9. That's a negative 9 and 12. See what I'm talking about? 22. These are both composite terms. So they're like terms combined into one term. Negative 9 plus 12. That's right. Plus the 2x is still in there on the left. Equals negative 2x. Now, subtract 3 from the side. 12 and a half, then. I am seeing lots of 12 and a half. Okay, one more. It's the last one. Looks a little different, but it can be so easy. There you go. 7a plus 1. All of that is over 2 equals 18. Now remember, that bar means a grouping symbol, so that stuff on the top is all glued together. And your secret is, this is a fancy way of writing divided by 2.
Hey, wait, real quick. Little Brian, give me that.
Okay? Watch up here, because I can see some of the front rows that got some bad stuff happening. So how about we just watch on this one? I want to multiply both sides by 2. Okay, now watch. Multiply by 2 gets rid of divide by 2. Start out 7a plus 1 equals 18 times 2. Finish it up.
for us to multiply.
Don't you need to multiply the other stuff by two?
Cause it's a thing, cause this is all glued together.
Yes, so just
So-
multiply the two by one by, or one by two.
This is all one term, so we only wanna multiply by 2 once.
Okay.
Once you do it once, that's good.
Sorry?
$35 divided by 14.
I'm gonna fix it, don't erase that, I'm gonna help her, okay? Let me get my hands straight, I'll be right back.
Is this homework?
We got,
Okay, listen up. The front side is the homework. The front side only. We're gonna do the back.
Thank you.
We'll do it tomorrow. Front side only. Front of worksheet.
Ow.
This is sick.
Wait, no, did I have a question before that?
You have pressed it. And then if you press it, you can have
I found it. This,
But that's right, so what's the...
well, not really, because you, here, you kind of treated this kind of funny. Here's your equal sign. And so, on one hand, you added 9 on the left, and you didn't come over here to add 9. That, normally that'd be a problem. Or you subtracted 9, but you didn't come over here and subtract 9. But here's what it worked out for you. Because on this same side, how much is a positive 9 and a negative 9 together worth? 0. So you did 2 things, but since together there was 0, it's like you added 0 to that side. So that's why